Hello, grade 12. So I'm going to continue with example 6 and 7. I'm just going to read the question out to you. So it says that calculate the ratio AS to SC if BC is parallel to TS. So we know that this is parallel to TS. And it goes on to say that TC, this line here, is parallel to PS. So let's just mark that down. And we have that this ratio BT to TP is 3 to 2. And they've given us a little hint, and they just said that let PA be equal to X. Okay. So because there's a whole lot going on here, I just want to color code these lines so we can see what is going on here. So that is parallel to that. And then we have that this one is parallel to this one. Okay. Right, so next thing I'm going to do is I'm going to work with my BTTP ratio. So we've got that BT to TP is in this ratio 3 to 2. And they've told us that, or the hint is let this be X. Okay, so, and we want to find this AS to SC ratio. So if we have a look here, this AS to SC ratio fits with two things on this side. First of all, it'll fit with the blue parallel lines. So we'll have AT, which is AS, to TB, which is SC. But then it also fits with the red ones. We have this AP, which is AS, to PB, which is SC. And that's what I'm going to do. I'm going to make two different things, and then we can solve for this AS-SC ratio. So let's have a look at the first one. So we're going to have AS to SC is equal to AT to TB. So we have the AT to TB. So I'm using the blue parallel lines. Okay. Now the reason why I said this is we have a line parallel to one side of the triangle. And the parallel lines that I used were the blue ones. So we have TS parallel BC. Okay. So I'm just going to fill in the information that we have here. So we have that AS to SC is equal to, now AT would be X plus 2 over TB would be 3. Okay, so we've got that one. Now what I'm going to do is I'm going to work with the red one. And again, we know that AS to SC would be equal to, now if we use the red one, it's going to be AP to PB. So we have AP, oh sorry, not to PB, to PT, just up to the red ones, up to PT. Okay, so this is the red one. And again, my reason for this, line parallel one side triangle. And the parallel lines that I used were PS parallel to TC. Okay, let's fill in our information. So we get AS to SC is equal to, now AP is X and PT is 2. So we have an AS to SC is that, and AS to SC is that. These two things are equal. So I'm just going to solve for X. So we get X plus 2 over 3 is equal to X over 2. This one equals this one. I'm just going to multiply up, and we get 2x plus 4 is equal to 3x. And if you solve for x here, you get x is equal to 4. So we still want to find this AS to SC. So what I'm going to do is I'm going to plug into, now it doesn't make a difference, this one or this one, and find out what our ratio is. I'm just going to plug it into this one. So we get AS AS to SC is equal to, now x is 4, so it's 4 to 2. And I can simplify this, and we get 2 to 1. And there is our ratio. Okay, the next one we're going on to is example 7. Okay. And if I just bring up the question there, question 7 is saying that PA is equal to 3 over 8 PQ, and 2PB is equal to BR. Calculate the ratios of A, the area of triangle PRA, to area triangle QRA, and then question B is BD to DQ. Okay, so what I want to do first is I just want to try and get these things looking like proper ratios. So I'm just going to divide by PQ here. So we get PA over PQ is equal to 3 to 8. Okay, and then with this one here, I'm going to divide by the BR and then divide by the 2. So we get PB over BR, RB, is equal to 1 to 2. Okay, so let's start putting this information on our diagram here. So if I just get my highlighters. So the first one I'm going to look at is this PA to PQ. Okay, so PA to PQ. So we've got PA to PQ, and that is going to be 3 to 8. So PA is 3 and PQ is 8. Now, because we have that, I know what AQ is going to be. AQ, if this whole thing is 8 and that is 3, this must be 5. Okay, so we've done that one there. That was from our green information. Then I'm going to have a look at this one here. This one here is saying PB to RB. So we've got PB to BR is in this ratio 1 to 2. So we have 1 to 2. And if I just have a look here quickly, just to try and link this information, we're looking for BDDQ. So this is B over here. Okay, so we're looking for BD to DQ. So I can see, and this is parallel, I can see that I can use this to this will be this to this. So let me link this information over here, and I get, because this is parallel to this, I can get that PC to CA will be the same as this PB to BR. So we get here 1 to 2 for that. Okay, so I'm going to stop there for now, and I'm going to start answering these questions here. I think we've got enough information there. So for question A, they're asking us, we want to find the ratio area of triangle PRA to the area of triangle QRA. So if we have a look at PRA is this triangle, and then QRA is this triangle here. I can see they are sharing a common vertex over here. Now, this is not a vertex, okay? You remember, guys, vertex is the pointy one. So this would be our common vertex. So if you remember from the previous slides, if they're sharing a common vertex, the areas will be in the ratio of the bases. So for this PRA triangle, the base would be this PA, and then for this triangle QRA, the base would be AQ. So we know that the base for this one is PA, and the base for this one here is your AQ. So what is PA? PA is 3 for that green one, and the AQ is 5. And we've answered that question. Now, the reason why I said this was because of a common vertex. That is why their bases are in this proportion. Okay? Now, if we look at question B, right, so for question B, this is what we want. We want this BD DQ. Okay. If I can find this ratio and this one, I've got this one to this one because this line is parallel. Now, if you have a look here, I don't know what this ratio to this ratio is because they're overlapping. I've got an orange one to a green one. So I can't say that's 2 to 5 because they're overlapping. So what I'm going to do is like I did with the previous examples, I'm going to find this one using my green and my orange. Okay, so first of all, if I have a look here, I know that AC to AP, you see, because that's the only green part I know for this AC part. So AC to AP. And that is what I want to find, guys. I want to find this one in terms of the green. Okay, equals. Now, I know that this one is equal to this orange bit, which is going to be now AC is 2. And then my AP to the orange is 3. Okay, so this little bit over here was for my green. And then this little bit is from my orange. And that is how I've linked the two bits of information from the two ratios. I've got my orange and my green, and that is the link. Okay, so just remember that this is the green bit. So we get AC to now AP for the green is 3 equals, and then we've got this from the orange. And now I can get AC on its own. So I just multiply up by the 3 and I get 2. Okay, so that means now we have for the green, we have that AC to AQ is equal to 2 to 5, because we've just worked out that for the green, that's our green bit. So AC is 2, and then AQ for the green is 5. Okay, now, because this is parallel, AC to AQ will be the same as this DB to DQ part here. So we know now, therefore, BD to DQ will be equal to 2 to 5. Okay, it's the same one as this. And the reason why I did this was line parallel, one side triangle. And I must just list what my parallel lines were. I used BC parallel DA. All right, grade 12s, I would like you to do exercise 4 for me, please. Thank you.